Okay, that was pretty cool, wasn't it, with the hammer and the feather? And you saw that they fell at the same rate. Okay, what we're now going to talk about is we're going to talk about the factors that affect how fast an object will fall through the air. So what are some things that you can think of that might affect how fast something is able to fall through the air? The terminal velocity. For instance, if it's a skydiver, their terminal velocity is about 120 miles per hour. What I mean by that, terminal velocity is they're going to accelerate all the way up to some final speed. So let's say this is our skydiver here. And they're going to keep on accelerating. So at first, right when they jump out of the airplane, they're just going to have one force on them, weight. They're not moving very fast at all. But then as they move faster and faster, there becomes a drag force. Still, you can see here that there's a net force, though, and it's still going to be accelerating, not at 10 meters per second each second, though. Eventually, though, the thing's going to be moving so fast that the air resistance force up is going to be the same magnitude as the weight down. Now, that doesn't mean they're not moving. That means that the net force is zero, which means the acceleration is zero. They're moving at constant velocity. And we call that terminal velocity because it reaches some ending speed. So I want to figure out what are the factors that affect how fast something falls. So ideas. The weight of the object. Why is that? Well, that's because the weight is going to be the same as the air resistance force. Okay? Any other ideas? Yeah, some people say that they've seen these people change their shape, you know, and that changes. It's going to be hard to check every shape, but I'm going to put that up here because I think that's a good idea. I just don't know if we can test it. Density. Okay, so the density of the object, that's kind of related to the shape a little bit, but there is another density here, and that would be the density of the material. So I'm going to put density here. And I think you're actually talking about two different densities, the density of the object and density of the material. Again, just like shape, there's going to be lots of different densities we could check. So that's going to be kind of hard to check. Any other ideas? The area. Okay, so yeah, the area of this. All right. Okay, so what are some things that we could check in class? Well, we could actually drop paper. Actually, we're going to drop coffee filters. And we can measure the area, and we can measure the weight of the thing. So those are pretty easy to check. The shape is kind of hard to change. So I'm not saying it's a bad idea, I just don't think that we could check it. So in lab, we're just going to kind of put that off to the side. Also the density, that's another one that's kind of hard to change. We're going to be dropping it through air, and the density of air, you can do a Google search to figure out how many kilograms per cubic meter. And we're going to be using coffee filters, so you could figure out the density. But we're going to keep it just on that. I think that's another good idea, it's just we can't check it. There's too many variables. Okay? All right, so what you're going to do is you're going to continue on with the bundle. You'll notice that there's a lab, drag lab document you need to download, a PDF document. And on that there's a link to a file. And the file contains 2 videos, and it contains 2 tracker programs. You need to download all 4 of those. When you open up the tracker program, it's all ready to go for you. So it already has the axis put in there, already has the coordinate system, it has the meter stick put in there. It's all ready to go for both of them. And when you open up the one tracker program, it knows which video to look at. So the purpose of this lab is to graphically and mathematically model the relationship between the terminal speed and the weight or drag force, you can think of it, because they're the same, right? In fact, maybe I'll just do that. I'm going to call it just drag force. And the drag force, F air. And between the terminal speed and the area. Notice there's two things we're checking out here. That's why there's two tracker programs. That's why there's two videos. Okay, so in the one video, when you open it up, you'll see these coffee fillers falling. They're already at terminal velocity. And the thing that we're going to be changing is we're going to be changing their weight, which is changing the air resistance force. How are we doing that without changing the area? Well, we're going to be stacking the coffee fillers on top of one another. So at first you're going to see, I think it's 6 coffee fillers that fall through, and you're going to figure out the velocity through the tracker program. Then you'll see, I think it's 4, then 3, then 2, then 1, something like that. In the other program, you're going to see, we're going to be tracking the velocity of these coffee fillers again with different areas. So they're all circular in shape, and we're changing the radius, which changes the area of it, because the area of the circle is pi r squared. And how are we keeping the weight constant then? Well, all the trimmings have been put on top of the coffee filter in kind of the shadow region, so there shouldn't be any air resistance on it. But they're all going to be the same weight. All you need to do, the first dot has been made for each one of the coffee filters that's falling. All you have to do is select the appropriate color and then continue tracking it.